Hi everyone, Summer here and welcome back to GoDevOps. In this new series, we're going to explore Podman from a practical and operational perspective. Now, this series assumes that you already understand container fundamentals. I already made a complete containerization series where we covered what containers are, how they work internally, all about images, registries, runtimes, volume, and much more. So here I don't want to repeat generic container theory again. Instead, we'll focus specifically on Podman itself. Now, before running our first container, let's quickly understand what Podman actually is. So Podman is a container engine. Its job is to pull images, create containers, run processes, and manage containerized applications on your machine. So one important thing about Podman is that it is daemonless. So unlike Docker, Podman does not rely on a long-running central daemon constantly running in the background. Instead, Podman directly launch and manage containers. Now, don't worry, we'll explore what that really means later in the series. For now, just keep the idea in mind. Another very important feature is rootless containers, meaning we can run a container as a normal user without needing root privileges all the time. And that's a very strong security advantage, and honestly one of the reasons why Podman is so popular in Linux and enterprise environments. And if you already know Docker commands, you'll notice that Podman feels very familiar. So most commands are intentionally very close to Docker commands, which makes adoption much easier. And now with that quick context in mind, let's move into a real scenario. So imagine you quickly need a web server, maybe for testing or local development or for debugging or for producing an issue on your machine. And instead of manually installing packages, configuring services, and modifying the host system, with Podman, we can launch a complete web server in seconds. And the important thing here is not just running the container. What matters is really understanding what Podman is actually doing for us behind the scenes.
So let's start with a single command, a Podman run command. You add the options, port mapping, the image name, okay. Now notice what happened here. The image was not already available locally, so Podman automatically pulled it from the registry for us. And then it created the container and started it immediately. So in the last line, we have the container ID that was created. Now let's verify that the container is actually running with a Podman ps command. And we clearly see here the container is running. We have the image being used and the port mapping that was configured. Now let's see if the web server is actually accessible from the host machine with a curl command. So it is actually accessible. And now if we open the browser and we'll look for the localhost 8080. So here we can see the Apache HTTP server default page running successfully inside the container.
And honestly, this is the moment where containers start feeling powerful, because with a single command, Podman downloaded an image, created a container, configured networking, launched the web server process, and exposed the service directly to the host machine. And the interesting part here is that we still haven't investigated how all of this actually happened. So now let's dissect this command piece by piece and understand what Podman really did internally. So let's start with the first part, with Podman Run. So the role of Podman Run is simple. It creates and starts a new container, but internally, several operations happen automatically before the container becomes available. So it's similar to pressing the power button on a laptop. From the outside, it feels like a single action, but internally, hardware initialize, service start, processes launch, networking activates, and many things happen before you finally see the desktop. And Podman follows a very similar logic here. So first it resolves the image name. Then if the image does not already exist locally, it pulls it from the registry. After that, it creates the container itself, configure networking, and finally launch the main application process inside the container. And all of that happen automatically from a single command. Now let's continue with the image name itself. So here we have in red the full image reference used by Podman, and it can actually be broken into three parts. So we have the registry, the namespace, and the image name. So the registry is where the image is the image is stored. The namespace helps organize images, and finally HTTPD is the actual image name itself. Now let's continue with another important part of the command, so the D option, and this option stands for detached mode.
To understand what that means, let's quickly run a container without detached mode. So we will do a Podman run, and we will use another image. Let's take the Nginx example. So now notice something important here. The terminal is attached directly to the container process, so we don't recover the shell because the terminal is currently connected to the application running inside the container. And this is actually a very important concept operationally, because without the detached mode, it's like directly sitting in front of the application console itself. And now I'll stop the container with a Control-C, and we recover the shell immediately. So now let's compare that with the detached mode. So with the previous command we have already seen. And the same image. So here, with the D option, Podman launched the container in the background, while immediately giving us back the terminal. So the application continues running independently from our shell session.
And finally, let's look at another extremely important part of this command. So the P option, this is port mapping, and this is one of the most important networking concepts when working with containers. So here the application inside the container listens on port 80, but containers run in isolated networking environments, meaning that the host machine cannot directly access container ports automatically. So what Podman does here is create a mapping between the port 8080 on the host and the port 80 inside the container. So when we access localhost 8080, the traffic is redirected internally to container 80. And a good way to visualize this is we can consider port mapping like opening a control door from the host machine to the container. And without that mapping, the service would still be running inside the container, but would be inaccessible from the outside. And this exact mechanism is something we'll revisit later when we go deeper into Podman networking. And honestly, this is already enough to see why containers are so powerful. So with a single command, Podman pulled an image, created a container, configured networking, and launched a working web server in seconds. But running containers is only the beginning. In real environments, we also need to manage them, to inspect them, to debug them, and to understand their life cycle. And that's exactly what we'll explore in the next episode. And if you enjoyed this video and want to follow the rest of the series, don't forget to like the video and to subscribe, and see you in the next one. Thank you.